All right, today we're going to dig into a quiet revolution that's happening on farms all around the world. It's a story about nutrition, it's a story about sustainability, and really, it's about a major scientific shift that is changing the very basics of how we feed the animals that feed us. It all starts with one of the biggest questions of our time. How can we possibly produce enough food for a growing population in a way that's better for the planet, better for the animals, and still makes economic sense? Well, the answer, it turns out, might lie in something incredibly small: the building blocks of protein itself. For decades, animal nutrition was pretty much dominated by this one concept called crude protein. And really, it's a blunt instrument. It's just a way of measuring all the nitrogen in feed to get a rough estimate of its protein content. But on the other side, we have a true precision science, focusing on the individual amino acids, the actual building blocks that an animal really needs. Think of it like the difference between a sledgehammer and a surgeon's scalpel. And this is where we get to the heart of the protein paradox. For years, we've just been feeding animals these diets that are super high in crude protein. The thinking was, hey, more is better, right? But here's the catch. Animals don't actually need crude protein. They have a very, very specific requirement for essential amino acids. And everything else? Well, it's just waste. Okay, here's a great way to picture this. Imagine you're building a house. The crude protein method is like dumping a giant pile of bricks, wood, and steel on a scale and just saying, yep, that weighs enough to be a house. The precision amino acid method, on the other hand, is the actual blueprint. It tells you exactly how many bricks you need, precisely where each beam goes, how many windows to install. One way is just total guesswork, the other is engineering. And the downside of all that guesswork is pretty significant. When an animal gets way more protein than it can actually use, all that excess nitrogen has to go somewhere. It gets excreted as waste, which makes the animals drink more water, which leads to wet, unhealthy living conditions, and it pumps a ton of ammonia into the air. And what's worse, that undigested protein in the gut, it becomes a feast for harmful bacteria, compromising the animal's health from the inside out. But what if we could give the animal exactly what its body needs and absolutely nothing more? Well, this is the breakthrough. Instead of just oversupplying protein and kind of hoping for the best, modern nutritionists can now formulate feed based on a super precise recipe of individual amino acids. This brings us to a really key idea: the ideal protein concept. Now, this isn't some vague goal. It's a hard scientific principle. The aim is to create a perfect profile of amino acids, totally customized for the animal's age, its species, even its environment, so that every single building block gets used for growth and health, leaving almost nothing behind to be wasted. It is the ultimate in nutritional efficiency. Now, this revolution didn't just happen overnight. For a long, long time, nutritionists only had a couple of amino acids that were actually cheap enough to add to feed. But as manufacturing technology got better and better, more of them became available. First, threonine, right around the year 2000, and then a whole suite of others in just the last decade, finally giving nutritionists the full toolkit they needed to build that perfect blueprint. So what does this all mean in the real world? Why does this matter? Well, this whole shift delivers what we can call a triple win, a massive positive impact across three totally different but equally important areas. Let's break them down. First up, the ecological victory, and this is a total game changer for sustainability. By cutting down on waste right at the source, inside the animal, we drastically reduce the environmental footprint of farming. And the impact is, well, it's huge. A meta-analysis of over 100 trials found that for every 1% you lower crude protein in a broiler's diet, while keeping those amino acids balanced, of course, you cut nitrogen excretion by a staggering 10.4%. I mean, that's so powerful that it's become a core part of major policies, like the EU's farm-to-fork strategy, which is all about making agriculture more sustainable. The second win is all about the animals themselves, because it turns out that what's good for the environment is also absolutely fantastic for animal health and well-being. Because there's less undigested protein floating around in the gut, the balance of microbes in there improves. And because there's less nitrogen waste, their living environment gets drier and has cleaner air, which directly cuts down on painful conditions like foot pad dermatitis. In pigs, it's even been linked to a reduction in stress behaviors like tail biting. It's just a clear win-win. And finally, the third win. It just makes economic sense. You might think, oh, this precision science must be expensive. But actually, it saves producers money. This quote from research on swine nutrition spells it out perfectly. By replacing expensive, inefficient protein sources like soybean meal with precise, targeted amino acids,
Farmers can significantly cut their feed costs, which is one of their biggest expenses, and they do it without sacrificing performance. So it's better for the planet, better for the animals, and better for the bottom line.
But, science is never that simple. Solving one problem often just reveals a brand new, more complex layer of challenges. And as nutritionists get better and better at this, they're discovering some really fascinating new puzzles to solve. A perfect example is something called BCA antagonism. Now, corn, which is a major feed ingredient, is naturally very high in an amino acid called leucine. The problem is that leucine and two other crucial amino acids, isoleucine and valine, all have to share the same breakdown pathway in the body. So when there's way too much leucine, it hogs all the enzymes, causing the other two to get broken down too quickly. And just like that, you've created a deficiency out of thin air and performance suffers. It's a whole new level of complexity. Nutritionists now have to think about things they never even considered before. The role of so-called non-essential amino acids, the different absorption speeds of amino acids, and even how the ratio of starch to protein in the diet affects digestion. The blueprint is just getting more and more detailed every single day. So where does this all lead? Well, it points to a future where we can truly do more with less. A future of food production that is more efficient, more humane, and more sustainable than ever before. This entire story is really a journey from a blunt instrument to a surgical tool. We've moved from these crude, rough estimates to incredibly precise formulations. And by understanding the fundamental needs of the animal at a molecular level, this science is completely reshaping the foundation of animal nutrition. And it leaves us with a pretty fascinating final question. In a world that's facing these enormous challenges in trying to feed itself sustainably, could it be that the answer lies not in some grand, sweeping changes, but in mastering the smallest, most fundamental building blocks of life itself?